Alright, we're working with exponents and shortcuts, and I'd like to give you two mixed practice problems so we can put some of these rules into practice. Let's start with this one, mixed practice 1. Okay, let's try 2x to the third power times 3x squared. Alright, it doesn't look quite like the examples, but we can sort this out. Remember that there's a lot of just multiplication going on here. There's an invisible multiplication sign between the 2 and the x, right? That's what 2x means, 2 times x. And there's multiplication here. When there's nothing in between two sets of parentheses, we understand it means multiplication. There's also multiplication here. And so it's all these factors being multiplied. And when we multiply, order doesn't matter. So I'm going to rearrange these factors. I'm going to put the two numbers next to each other. I don't need the parentheses anymore. I put 2 times 3 next to each other. And then I'm going to put x to the third times x to the x squared next to each other. Again, order doesn't matter when we multiply. That's why we can do this. This is easy to answer. Now this is x times x times x times x times x. That's how many x's being multiplied? 5 of them. Remember what the shortcut rule is? When multiplying like bases, just add the exponents. When multiplying like bases, add the exponents. That's our product rule. Okay, there's our first example. Hopefully that'll help with your homework. Now let's try mixed practice number 2. We're going to combine a couple of rules. This problem will have 3a squared raised to the third power times negative 4a to the fifth power. Alright, there's a couple things going on here, but let's look at this first part first. This 3 outside means that everybody inside the parentheses wants to get raised to the third power, not just the a squared, also the 3. So we distribute that power to both of the factors inside. So I'm going to rewrite this with 3 raised to the third power. Now remember there's an invisible times sign here, so I'm going to write down times. A squared raised to the third power. Now a squared raised to the third power is that 3 of those multiplied. Well, that's a times a times a times a times a times a. That's a to the 6th power. But remember what the shortcut is? When you're raising a base to a power, then to another power, you multiply those powers. That is our power rule. When raising a base to a power, then to another power, multiply the powers. Alright, now going on, there's invisible multiplication here. There's nothing outside of this parenthesis, so there's nothing to raise the negative 4 to, so I'm just going to write down negative 4. And again, it's just a to the 5th power. There's nothing outside to do to what's inside. Now remember what we did up here? We rearranged things so that we can multiply the numbers and multiply the variables. Now, I'm going to do it in my head this time instead of rewriting it. These two together are going to be, well, you know what, maybe I will rewrite it. 3 to the third times negative 4, because I'm going to have to enter that in my calculator. I'm not going to do that in my head. Times those two, a to the 6th times a to the 5th. Alright, which rule are we using now? We're using the product rule. When multiplying like bases, add the exponents. I have a base a to the 6th times base a to the 5th. That's going to make a to the 11th. And this part here, I'm going to do in my calculator. 3 to the third power, 3, turn it on, 3 power up to the third power. That gives me 81. Oh, excuse me. 3 to the third power is 27. And I'm going to multiply that by negative 4. Alright, the negative key, and then press 4. Alright, and we get negative, whoops, sorry about that, camera slid. We get negative 108. Alright, So, negative 108, a to the 11th power. Too lazy to put the times sign there. Whoops, that's an 8. And there's our final answer.